Welcome to Nasir Soft. In this video, we will talk about a very important topic in statistics, that is the normal distribution and the z-score or z-score. What it means. After watching this video, you will not only learn this topic theoretically, but I will also explain it practically through Python code. So the normal distribution is very simple. It's just like is also known a Gaussian distribution is a probability distribution that is symmetric bell shape. Okay, it is one of the most important concept in statistic and data science because many natural phenomena of data set approximately following these distributions. Okay, so if you're familiar with the histogram is basically a frequency distributions. For example, on the right hand here, the height of some persons are, the histogram of the height of the persons are this. Here you can see that uh, on the average both side. Okay, so the data is that distributed. And for example, if we talk about the normal distributions, at the center we have mean value, and on the left side and right side we have first standard, second standard deviation, and third standard deviation. Okay, so you are already familiar with the standard deviation. So this is just like a data distributions. Okay, uh, across the mean. Okay, so the normal distributions key concepts, key characteristics are, okay, the symmetric around the mean. It's basically the bell shape. When you basically on the top of histogram, when you draw a curve, so it's like a bell shape. Okay, and this is some abbreviation that standard deviation, about 68% of data lies within first standard deviation from the mean, about 95% data lies, okay, within the second deviation, and 99.97 lies with third deviation. And this diagram basically showing all these. What is z score? Okay, so the z score, also called the standard score, it is nothing but how it is tells how many standard deviation a particular data point is from the mean of the data set. This is very simple. On the next slide I will show you with example, so you will familiar with it. It helps standardize data, making it easier to compare data points from different distributions. The formula is very simple, that is equal to each data point minus its mean divided by the standard deviation. Okay, so we will calculate her for a data point from its mean. Okay, so this is, so for example, this is our student data sets, and inside this here you can see that each student's name and total marks are showing. They basically, Nasir gained 13 marks, Abdul Majid got the 12 marks, and something like. Overall average of this data set is, or I can say that the mean of data set is 10.44. Okay, so now if you calculate the standard deviation of this data, the standard deviation is 1.57. If you are not familiar with the standard deviation, on the video description my another standard deviation video link is mentioned. So you can first basically watch that specific video, then you will familiar with the standard deviation. Okay, so the standard deviation of this data set is 1.57, and overall mean is 10.44, that is average. Okay, so how we calculate the z score? We can calculate the z score through this formula. Okay, so to calculate the z score for each data point, for example the marks is 13, we will subtract its overall mean, that is 10.44, and then divide by standard deviation, that is 1.57. Similarly, for the Abdul Majid, the marks is 12 minus overall average, that is 10.44, divided by standard deviation 1.57, and we get this type of marks, that is 1.63, 0.44, and something like this. So this is called the z score. You are already familiar with the z score. And how simple is it? Okay, so now let's calculate the z score and the normal distributions practically in Python. Both of these will work in order to determine the outliers. Let's see practical Python code. Okay, so the dataset is basically the heights of a person, and the dataset you can download it from the in video description. The download link is also mentioned. I have copied this dataset from a YouTube channel, that is Code Basis. Okay, when you basically when we read the dataset through pandas and we print out, here you can see that we have a gender and a height of persons. Okay, if through the data dot describe, if I here print, it shows me all the the mean of the data, that is 66.36, standard deviation, minimum, maximum, and 25 percentile, 50 percentile, 75 percentile values, and something like. Okay, when we create the histogram, okay, through this cburn library method, that is his plot, and basically the in which column we want to the height of the persons, and we place the kd is equal to true. What it mean, also show the curve. Okay, for example, if we write here false, and here you can see this, now the curve will be not showing. Okay, so through this kd true and false, we will show the curve with the histogram. Okay, here you can see that at the here this is the mean at the center, and the left and right distributions of the data is showing us. Okay, so next, what is the mean of overall data? Okay, through the data dot height column dot mean method. Okay, and we save it the mean inside a variable. When we print it, the mean is 66.36. Similarly, we calculate the standard deviation of the whole data. Okay, that is data that height, the column name, and then the standard deviation method, and we save it inside the standard deviation variable, and the standard deviation is 3.84. Okay, now how we can calculate the z-score? You already know through this slide, that is the z-score is basically nothing but each data point minus overall average or mean divided by overall standard deviation. So what I did here, I create a new column. Okay, and inside this, each data point minus the overall mean, which we calculated here, and divided by the standard deviation, and for each it will store inside a new column, that is z score. If I print it out, here you can see this, after the heights a new column z score is created, and inside the z score each individual value is. Okay, so what, now we will remove the basically anomalies and outliers. Okay, through the z-score method. Okay, the z-score method says if the z-score value is greater than 3 or less than minus 3, okay, that this is the normal distribution, and if a value exists after the third 3 and minus 3, okay, then that will be the outliers or anomalies. Okay, for example, I check inside my data how many values are where z score is greater than 3, sorry, and here you can see that the greater than 3 values are this. And similarly, we can check inside how much in our data when the anomaly is less than, okay, less than, for example, 3. Here you can see, so the value should be between minus 3. Okay, so the value should be between minus 3 and 3. How many values are where is the less than minus 3? For example, here you can see this, there are only two values that are anomalies. The data is basically the less than minus 3. How we can remove now the outliers or anomalies? For this, inside the data, okay, here I make a condition where z score is greater than equal to minus 3 and the z score is less than equal to 3, that will be no outliers. Okay, so we saved it inside a new data, that is data variable, that is data underscore no outlier. And if I print its shape, here you can see that the three anomalies are now, the two anomalies are removed, and we have this. Okay, so we have these things of the, if we print out instead of its shape, if we print out all the data, here you can see that now this data is pure from the anomalies or the outliers. So here how you can remove the outliers through the z-score method, okay, in normal distributions. So this is very simple. Okay, the z-score is the data should be between the minus 3 and 3. Okay, when the data comes, if the data is greater than less than equal to minus 3 and greater than equal to 3, then that will be anomalies. So I hope you have understood about the basic concept of normal distributions and z-score. If you have any question, you can ask your question in video comment section. A question link is also mentioned in video description. Don't forget to subscribe my channel for more informative videos. Stay blessed. Have a nice day.